Zach from DKE. We built Gnat, the Gray Network Analysis Tool. Gnat is a tool for analyzing gray social networks that are normally a little more difficult to analyze. We use LSI and NLP to perform sentiment analysis on the posts after obtaining them either through RSS feed or API, and then we can show how positive or negative the posts are and correlate between them. Now, I have in the video description a link to the interface so you can try it out yourself, because a lot will get lost in translation here. So if you wouldn't mind doing that, that'd be great. You know, pause the video or something. Anyways, what this does is, what we're doing here is we're pulling posts from Steemit, and then we're performing a latent semantic indexing on them to determine how positive, negative, or neutral they are. We also are able to extract topics. It actually comes back in the response, and it's in our GitHub repo, but we have placeholder topics right here. We just didn't have time to populate them from the response. Now those topics can then be matched up and searched on one of the networks. These are actually the top topics for the network itself. So the idea here is to be able to take the topics that are extracted from this content and then identify a relationship between those and the most popular ones. And these will actually load posts here. Again, we ran out of time. We didn't have time to do the full sentiment analysis on these, but the code is mostly complete. The graph component we didn't have time to get to. We were going to use Sigma.js, which works very nicely. We just didn't have enough time. We were able to integrate Steemit and Mastodon, and are able to pull posts from both of those or a combination.
So under the hood, this is basically just a Flask application that implements a RESTful API that the React front end interacts with and uses to make requests to and from the different networks that we're gathering data from. We've already implemented actually two different data feeds. One is the Steam network, the other is Mastodon. So I'll go ahead and I'll walk you through some of the functionality we have here with the RESTful API. First one is pulling the most recent data from an RSS feed for the Steam network. You can see we got quite a bit of data here. We generate some tags based on the summary details. We'll run this through translation if it happens to be in a different language. We also do sentiment analysis on it as well. We also have a way to search through this network by tag based on the tags that we generate, and I'll demonstrate that here with a simple curl request. And you can see here we have the same set of data, or normalized I should say. It's one of the beauties of the RESTful API is it's able to pull content from many different sources and normalize it in a way that our front end can process it and simplify it for the user. Another functionality that we've implemented is what we call the analyze this functionality, where you can basically just send any sentence to the RESTful API and it'll run it through the sentiment analysis. So I'll demonstrate that here. Let me go ahead and clear that. And you can actually send this an arbitrary set of data. And now I'll go ahead and demonstrate my favorite component here, which is the Mastodon feed. This is actually a live feed that updates and performs sentiment analysis on the feed as it's being shared amongst the users. So I'll have to go ahead and start that up. Now if we go and make requests to the Flask server, you can see the same type of analysis is being performed on the data from the Mastodon network, but it's updated live as the posts come in.
You've seen the back end, you've seen underneath this computer, and you've seen the front of it, you've seen the dashboard. You can probably tell that this is scalable, reliable, and designed properly. Gnat already scrapes data from the two most important distributed social networks in both API and RSS format. This tool analyzes every part of this data. For example, what you see here is a real-time video of just the metadata from just the photos that people are posting right now. As you can probably see, this metadata contains some very interesting things. You might notice things like which direction the camera was pointing, or you might see the location, you might see the make and model of the telephone, and the people that took it. But I'm more excited about the fact that we're cryptographically signing every one of these photos. That's similar to what Bitcoin does. That means that each photo has its own unique signature. And if you were curious, for example, to see if that photo was posted by two different people in two different parts of the world, now that's very, very easy to see because they have the same signature. We can also cryptographically sign every other part of any kind of data, such as username, the time it was sent, or the whole message. This gives researchers a powerful tool to analyze vast quantities of data. Gnat is already running, and you can check it out for yourself on our GitHub.